which is so much easier than actually adding them or subtracting them, which is sort of weird because you're thinking, gee, multiplication was always hard. But with fractions, piece of cake, if the cake were made of soy. So let me show you what I mean. Let's take a look at an example. Let's now multiply these two fractions. So 1/4 times, remember the dot here we use for multiplication, times 4/7. All right. Well, here's the simple fact about multiplying fractions. All we have to do is multiply the tops, so multiply the numerators, and then multiply the denominators. It's literally that easy. So if we try this one together, what we do is we would take 1 multiplied by 4 over 4 multiplied by 7. That's it. Now we just have to do each of the two multiplications, but that's easy because the top is just 1 times 4, which is 4. 4 times 7 is 28. And so we see the answer of 4 over 28. Now, if you want to simplify that, you'd notice that there's actually a common factor. It's 4. So I could write this as 4 times 1, 4 times 7. And then you can see that common factor. And so we know that since I'm multiplying the numerator and the denominator by the same non-zero number, then I can write this as just what we get when we get rid of that number. So the answer is 1/7. Here's a sort of cool thing. Did you notice that you could sort of see the 4 in the numerator and the 4 factor in the denominator way back up here? Yeah, it's right here. There's the 4, and there's the 4. So if we were really sort of sneaky, you could actually have done this multiplication question without ever multiplying any numbers, right? Check it out. You put these two things together, you write them like this, and then you sort of realize that the 4 over 4, that's equivalent to just 1/7. Isn't that neat? So sometimes multiplication doesn't even require you to do anything. That's a good question. Anyway, we're going to see this theme in the next example too. Sometimes if we try to simplify the quantity first, we actually end up doing less work. So let's check this out. 8/11 times 3/4. Okay, well let's first of all just try to do it using the rule. The rule is that you just multiply the tops, 8 times 3, multiply the bottoms, 11 times 4. And so what do we see? Well, the numerator will give me 24, while the denominator will give me 44. And now, can I simplify that? Well, is there a common factor? Now, actually, I see the common factor is actually 4. But let's pretend that we didn't see that. One thing that I think we can all agree upon is that both the numerator and the denominator are both even numbers. So let's just factor out the 2 first. Because this, by the way, is how I do it in real life. I start off very slowly. So then I see since I have 2 multiplying the numerator, 2 multiplying the denominator, that's equivalent to just 12/22. And now I see a common factor of 2 again. So I can write it as 2 times 6, that's the numerator, 2 times 11, that's the denominator. And so now I can think about getting rid of the 2's. And I have 6/11. And that's as simplified as I can get. So there's the answer. So there's one way of actually doing this multiplication. That's one way. Let me now show you the sneaky way. So this is method 1, using the actual definition of what it means to multiply. Let's check out the same question using the sneaky way. The sneaky way says, let's try to do as few multiplications and simplifications as possible. So the first thing I do is I'm going to just write 8 times 3 in the numerator, 11 times 4 in the denominator. And then notice that in 8, there's actually a factor of 4. So I could write this as 4 times 2 times 3, all divided by 11 times 4. So that's the denominator. And now you can see the 4/4 common factor. And so I know that that's equivalent to what I get when I remove those 2 factors from the numerator and denominator. And so I just see 2 times 3/11. And what's 2 times 3? Just one multiplication. 2 times 3 is 6/11. That's my answer with method 2. which is sort of the factor way, factor first. And look, it's the exact same answer as we got before. In fact, if you look at this really carefully, what you see is that all I can do is just look at this and try to find common factors of the top, common factors of the bottom, and then just do any multiplication after I've already simplified. There's a great sneaky way of getting this question. Let's try one last one here, and just let's use the sneaky way right out of the starting block. 3 over 14 times 2 over 15. Well, we know the answer is going to be 3 times 2 over 14 times 15, because that's the rule for multiplying fractions. You multiply the numerators, you multiply the denominators. But now, instead of actually multiplying, well, 3 times 2 is pretty easy, that's 6. But 14 times 15, that actually is going to require us to think a little teeny bit. So let's see if we can avoid that by factoring. Well, the 14 I can write as 2 times 7. And the 15 I can write as 3 times 5. Well, look, check it out. I've got a 6 on the top and a 6 on the bottom. I've got a factor of 2 in the numerator, a factor of 2 in the denominator, a factor of 3 in the numerator, a factor of 3 in the denominator. So in fact, I can simplify this and say this is equivalent to, well, in the bottom, what am I left with? 7 times 5, that's 35. What am I left with on the top? This is a classic mistake that a lot of my students make. They say, oh, there's nothing left on the top, you took everything away. So they'd write 0. But that would be incorrect, because we always have to remember that if we're going to factor stuff out, there's always an invisible number 1. Because remember, 1 times anything is just the anything. So technically there's a 1 there, and so the answer is 1 over 35. So multiplication fractions, not a big deal, especially if we try to simplify that product first before we actually do multiplications. Cool. I now want us to start to think about how to multiply fractions. And it turns out we can just think of multiplying fractions in a way, in certain special cases, by repeated additions. Let me show you what I mean. Let's take 7 and multiply it by 1/9. Well, what is this? Well, if we think about what this means, it means that I have 7 copies of 1/9. It means I've got 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9. Well, let's see. How many 1/9 do I have? I've got 1, 2, 3, 4, 5, 6, 7. 7/9. And that's the answer. 7/9. So that multiplication was actually really easy. 7 times 1/9 is 7/9. Fun! Let's try another one. 2 times 1/10. Well, again, we could think of this as repeated addition, because we could think that I just have 1/10 plus 1/10. We add 1/10 to itself 2 times. And what is that? Well, if I have 1/10 plus another 1/10, I have 2/10. So I see 2/10. And actually, that can be simplified a little bit, can't it? Because I have a factor of 2 in the numerator. I also have a factor of 2 in the denominator, 2 times 5. And so this can be simplified to 1/5. So using this technique of repeated addition, I see that 2 times 1/10 is equal to 1/5. Very cool. All right, one more. I'm going to show you one more because these are so great. 5 times 9/10. Well, now we're going to actually start to build the idea of multiplication for real. And the way I want us to think about this, since we've already seen the pattern, is I want to write 5 as a fraction. So I'd write 5 as 5 over 1, because that's what 5 equals. And I'm going to multiply by 9 over 10. And following the rule that we've developed here, what I see is, what I should do is take the numerators and multiply them together, and then take the denominators and multiply them together. So in this case, I'm going to see 5 multiplied by 9 divided by 1 multiplied by 10, which is going to be 45 divided by 10. So 45 tenths is the answer to this product. And notice that we did this in a different way than the previous examples. What I did here was I took 5 and wrote it as 5 over 1, and then I multiplied the numerators and multiplied the denominators. Notice that that actually holds in the previous examples as well. Think of 7 as 7 over 1. 7 times 1 is 7. The 1 times 9 is 9. It holds there too. And this is the way we actually multiply fractions. Now, 45 tenths is a fine number, but we could actually write it as 4 1/2, which is even prettier. So you can see that multiplication of rational numbers, fractions, it's not a big deal. We start off by thinking about repeated additions, and we try to uncover a pattern, and once we have the pattern, we're home free. Neat. I'll see you soon. multiplying two fractions together, not a big deal. But when we're looking at mixed numbers, it becomes just one tiny bit more tricky. Once we realize the trick, it's not a problem. Let's take a look at some examples and see that multiplying mixed numbers, not a big deal. So let's start off by just taking a fraction multiplied by a mixed number. So here's a quarter, and I'm multiplying it by 1 1/3. Now, how are we going to multiply this? Well, actually, I want to remind you exactly what 1 1/3 means. So I want to actually look at this close up and personal. So let's take a look, a real close, hard look at this. 1 1/3. Now, what does that mean? What that means, if you enlarge it to show detail, is actually this. It's technically 1 plus 1/3. In fact, when you read it that way, right? We say 1 and 1/3. And remember that the word and usually implies addition. So we have 1 1/3. So if you want to do this multiplication with this, we have to remember the rules of the orders of operation. And that tells us that we have to do the multiplication first. So this whole thing really is one piece, and we have to multiply. So what needs to be done? I've got to turn this into one piece, one number. How do we do that? Well, we talked about how to create an improper fraction from this. The little secret is to take the 1, multiply it by the denominator, and then take that answer and add the numerator and write that all over the denominator. So in this case, you can look at it and see 1 times 3 is 3. You add 1, you get 4. This is 4/3. And if you think about it, 1 1/3 is actually the same thing as 4/3. Once you make the conversion into an improper fraction, we're home free. We know what to do. So let's try it together. So first we do the little conversion. No multiplication yet. I'm just converting it to an improper fraction. So 1 times 3 is 3, plus 1 is 4 over the denominator 3. Now I can do the multiplication, which remember is just multiply tops, multiply bottoms. But before you multiply, can you simplify? Heck yes. I have a common factor of 4 on the top and the bottom, so this is equivalent to just the 1 over the 3. The answer is 1/3. Cool beans. Let's try another one. Here I have 1 1/7, and I'm multiplying it by 3/4. What do I do? Well, the first step is to change the mixed number into an improper fraction and then use the method we know for multiplying fractions. So what do I convert this to? Well, I just look at this and I see it's going to be 8/7, but let me show you how I did that. 7 times 1 is 7, plus that 1 is 8. So I have 8/7 multiplied by 3/4. The rule is 8 times 3, 7 times 4. Can I simplify? Yeah, because that 8 is actually 4 times 2. But don't forget to write the 3. That's just the 8, the 3, and 7 times 4. And look, check it out. There's a common factor on the numerator and the denominator, so that's equivalent to what we get if we just left those out. And that's 6/7. And that's the answer. So this equals 6/7. Not a problem. This is great. Let's try one last one just for fun. 3/5 times 2 2/3. Again, this is a mixed number, so the first step in this multiplication question is to first convert this to an improper fraction. So here we go. What do? I take 2 times 3, that's 6, and then I add this 2, that's 8. So I have 8 over that common, same denominator, 3. Now what? Well, now I multiply the numerators, multiply the denominators, and look how lucky we are. This is our lucky day. We, again, see a common factor of 3 in the numerator and denominator, so this is equivalent to just 8/5. 8/5 is a perfectly fine answer. Great. If they asked us to write that as a mixed number, because notice it's actually an improper fraction, the numerator is actually greater than the denominator. So if we did a little long division, what we'd see here is that this is 1 3/5. So if we convert that to a a mixed number, we'd see 1 3/5. If we left it as an improper fraction, we'd see 8 over 5. Both are perfectly fine answers. It just depends upon what the person who's posing the question, what form they want us to phrase the answer. No big deal. Either one's correct. They're both the same number. And the secret is, when we're multiplying a fraction and a mixed number, take that mixed number, transform it into a fraction, and you're on your way. Let's take a look at how to multiply two mixed numbers together. Well, it turns out we already know what to do. We just have to convert each of the mixed numbers separately into a fraction, in fact, an improper fraction. Once we have that, we're all set. Let's take a look at an example together. 2 1/3 multiplied by 1 1/5. What do we do? First step, convert everything to improper fractions. Because multiplying fractions is so easy that we want to do that. So here, I'm going to first take this piece right here. How do I do it? I take the 2 times the 3, that's 6, and I add 1, that's 7. So I have 7 over 3. And now what do? Well, now I multiply. And what's this fraction going to be? Well, 1 times 5 is 5, plus 1 is 6, over 5. So this is the improper fraction version of this. This is the improper fraction version of this. But now I've got two fractions I'm multiplying, no problem. Multiply tops, multiply denominators. I could actually multiply all that out, but let's see if we can simplify first. Well, the 6 I can write as 2 times 3. And now I see a common factor in the numerator of 3 and a common factor in the denominator of 3. So this fraction is equal to the fraction we get by removing those common factors. And so I see 7 times 2, which is 14, over 5. So the answer is 14 over 5. But if you wanted to write this as a mixed number, we would long divide, and what would we see? We would see this also could be written as 2 4/5. So if we convert this to a mixed number, so either answer is correct. It just depends upon the form that the questioner wants the answer to be given in. Either one of these. Neat. They're both the same. All right. Are you ready? How about 1 2/5 multiplied by 1 1/4? Well, what's the first step? The first step is always the same. We have to convert each of these mixed numbers into an improper fraction. Because once we have two fractions, even if they're improper, we know how to multiply them. Multiply tops, multiply numerators, multiply bottoms, multiply denominators. So what's the improper fraction version of 1 2/5? I take the 1, multiply it by the 5, that's a 5. Add the 2, I get a 7. 7 over 5. And then I multiply that by the improper fraction version of 1 1/4. So 1 times 4 is 4, plus 1 is 5 over 4. Now let me show you something here. Already, because we've looked at so many of these questions, I'm beginning to see right away there's a factor of 5 on the denominator. There's a factor of 5 on the numerator. So I could write the next step. The next step, which would have been 7 times 5 divided by 5 times 4. But right here, I'm going to actually take an extra little secret step and notice that I have, since I'm multiplying, the factors that are common already in sight. And so I could just jump right to writing 7 over 4. Since this is actually 7 times 5 over 5 times 4, that's a common factor of the numerator and denominator, and I can get rid of that. So that's a perfectly fine improper fraction answer to this product, 7 over 4. If you wanted to write it as a mixed number, you would have to actually peel off a 1, and we see 1 3/4. So either one of these answers is correct. It just depends upon how the person who asked the question wants us to answer it. So pretty cool. Let me show you one last question. It's a little teeny bit different. 4, the number 4, the whole number 4 times 2 and 1/9. Now, we can proceed in the usual way if we wanted to, which is to convert this to an improper fraction and then do multiplication. But let me show you a really great, easy way of doing this. And that's to remember what 2 and 1/9 means. Remember what and means? And means plus. And that's just one whole big thing right there is a number. It's 2 and 1/9. So if I write that out, I'd see 4 times, and this is just going to be one number here, 2 and 1/9. Now I want us to see that this is really the exact same mathematical statement. Because here's the 4, here's the 4, here's the times, and this number is 2 and 1/9, and this is 2 and 1/9, but it's all one number. So I put them in these parentheses. Well, when you look at it this way, now we can actually use the wonderful distributive property that we know that multiplication and addition enjoy to take the 4 and multiply it by the 2, and then add it to taking the 4 and multiplying it by the 1/9. So you could actually jump right to 4 times 2 plus 4 times 1/9. And so what does this give me? Well, 4 times 2 I know is 8. And 4 times 1/9, well, remember 4 is the same thing as just 4 over 1. And so I multiply tops, multiply the bottoms, I just see 4 over 9. And how can I write that? I can write that as a mixed number by just remembering the secret code. 8 and 4/9. So when you're taking a whole number and multiplying it by a mixed number, it's actually sort of sneaky. If you want, you could break up that mixed number into the sum of the whole number part plus the fraction part. But make sure you put parentheses around that whole thing. That's just one number. And then use the distributive law, and out comes your answer. Neat stuff. Congratulations. You can now multiply mixed numbers. Pretty neat stuff. I'll see you soon. Here we're going to start to divide fractions and take a look at mixed numbers altogether. Now, dividing fractions, that's kind of tricky business until the secret unfolds. And then it's really, really easy. So to warm up to the secret of the division of fractions, what I want to do is consider an interesting question that involves a new idea. Now let's take a look at the fraction 1/4. What I'd like to know is, what's the number that I have to multiply a quarter by in order to yield 1? So let me write that down. I want to know 1 over 4 multiplied by some mysterious number. I could call it x, but it's just between us, so forget about it. And I want that to equal 1. And the question is, what's the right answer? What's the number that goes in there? Well, if you think about it, the answer is going to be 4. And you can think about it in a couple of different ways. You could just think, well, 4 multiplied by 1 over 4 is 1. Or you could remember that I can always think about 4 as 4 divided by 1. Because any whole number is equal to that whole number divided by 1. So really, we can see that we have a 4 on the numerator factor, a factor of 4 in the denominator, and so we can see that that's equivalent to just 1 over 1, and 1 over 1 is 1. So another way of writing this is to notice that 1 over 4 times 4 equals 1. This answer 4, or if you want to write it this way, 4 over 1, they're both the same. That answer is known as the reciprocal of 1/4. The reciprocal of a number is that amount which you have to multiply the first number by in order to produce 1. So when you have a number and it's multiplied by something else and you yield 1, that something else is called the reciprocal. Let's take a look at another example and see if we can find the reciprocal. Let's find the reciprocal of 2/3. How do we do that? Well, I think to myself, 2/3 multiplied by some mysterious thing, I could call it x, but let's not, has to equal 1. That's what's required of this mysterious number in order for it to gain the label reciprocal of 2/3. Well, okay, what's that number? Well, if we think about what we need to do, what I need to do is I need to be able to reduce the final answer that we get so that I'm just left with 1. Well, that means since I've got a 3 in the denominator here, I best have a 3 in the numerator in order for those 3's to be able to be simplified. Similarly, since I have a 2 in the numerator, I'm going to want to put a 2 where? In the denominator. And so what I seem to be guessing is the following. 3 over 2. Now let's see if that's really correct. Let's check it. So what's 2 times 3? I'm sorry, 2 divided by 3 times 3 divided by 2. Well, that's 2 times 3 over 3 times 2. And look, we have a common factor of 3 on the top and the bottom, numerator and denominator. We have a common factor of 2 in the numerator and denominator. So in fact, that's, you can imagine just crossing them all off. And remember what's left over. It's not zeros. There's always invisible 1's. So I get 1 over 1, which is 1, and it checks. So the reciprocal of 2/3 is, in fact, 3/2. And notice how we did that, in fact. We took the 2/3, and we took the roles of the 2 and the 3, and we kind of flipped them over. And that's how we got the 3/2. 3/2 is the reciprocal of 2/3. Let's consider a mixed number now. 5 1/4. Well, how do I find the reciprocal of that? The first thing I have to do is convert this into an improper fraction. So the first step is to convert it. So the first step, before we even do anything, is to write this as an improper fraction. Well, 5 times 4 is 20, plus that 1 is 21. So I have 21 over 4. Well, now I can use that fraction to figure out what its reciprocal is, because it's that answer, so that when I multiply 21 over 4 by that number, we produce 1. And what's the answer? Well, now we'll begin to see how to operate here. Whatever we had on the top of our original fraction, that becomes the denominator for our reciprocal. And whatever was the denominator for our original number, we make that the numerator of the reciprocal. And so the reciprocal of 5 1/4 turns out to be 4 over 21. And so you can see finding reciprocals is not that bad. With mixed numbers, we first have to convert it to an improper fraction. And why would we use this? Well, it turns out this is going to be the key to dividing fractions by fractions.
Well, fractions are great fun, and rational numbers, which is just the fancy way of saying fractions, are wonderful. But it's interesting that when we combine them together, sometimes it's a little bit tricky, especially if we're dividing one fraction by another. So it turns out that division of fractions is really, really tricky. So if we work through it carefully, you'll see it's not a problem. Let's take a look at an example. So here's what I want us to think about together. The example I want us to think about is 3/8 divided by 3/4. 3/8 divided by 3/4. Now, once you know the trick, it's no problem. And here's what we do. We take the 3/8, and now we're going to multiply it by the reciprocal of 3/4. And that's the trick. To divide fractions, what we do is we take the first fraction and we actually multiply it by the reciprocal of the second. Now, the reciprocal is just a really, really fancy way of saying just flip the numerator and denominator. Just toggle between the top and the bottom, and then you've actually taken the reciprocal, just flipping the fraction. So take the first fraction and multiply it by the flip of the second fraction, and then you've got it. So if I want to take 3/8 and divide it by 3/4, that is equal to 3/8 times 4/3. So now I'm looking at a multiplication question, 3/8 times 4/3. And we know how to multiply fractions, I hope. All we have to do is multiply the numerators, multiply the tops, and then divide that by multiplying the bottoms. So 3 times 4, we know that's 12, and then we divide that by 8 times 3, which is 24. So we see the answer of 12 over 24, or 12/24. Now, actually, if you want to simplify that and write that in simplest terms, we could actually do that by finding, common factors and seeing, for example, 12 is 2 times 6, and 12 is just 12. It's 2 times 6, but it's just 12. And 24, notice, is 2 times 12. So we have a 12 on the top. We have a 12 on the bottom. If we simplify that, we just see 1 over 2, or a half. So here's the amazing lesson we discovered. You take something as complicated as 3/8 divided by 3/4. We now see what that equals. It equals just simply 1/2. How awesome it is when we actually realize that division of fractions is nothing more than taking that second fraction and flipping it and then multiplying the fractions together. So always multiply by the reciprocal, and you'll be good to go. Enjoy dividing fractions for yourself, and I'll see you soon. Dividing numbers in general, that's really hard, isn't it? I think it's hard. And you know what's even harder? When you're dividing mixed numbers. Wow, that's really, really hard. So let me just tell you how to do it, and then let's take a look at an example together. All you have to do is take those mixed numbers and first convert each one to a fraction that's bigger than 1. Now you've got 2 fractions that you have to divide, and that's now not a problem, because you know what you do. You take the first and you multiply it by the reciprocal of the second. So you flip and then multiply together. So if you remember all that, then you can actually look at any division of any mixed numbers at all. Let's take a look at an application and have some fun. Well, 1 serving of Roberto's favorite yogurt, I wonder what flavor it is 6.5 ounces. That's 1 serving of his favorite yogurt. Here's our challenge. How many servings are in a 16.25 ounce container? So a 16.25 ounce container, and we want to know how many 6.5 ounces there are in there. That's actually a division question, because I want to take the 16.25 container size and I want to divide it by 6.5 and see what we get. So here it is. I'm taking 16.25 and I want to divide it by 6.5. Well, you see, now we're dividing mixed numbers. Do you see? This is perfect. I just told you what to do. We first have to convert to fractions that are bigger than 1. So you know how to do that. The first thing I do is I take the 16 and think of that as 16 over 1. And so I think of 16 over 1 and a quarter, which means 16 over 1 plus a quarter. And so I have to get a common denominator. I multiply the 16 and the 1, both those guys, by 4, so 4 over 4, and I see 64 over 4. 64 over 4 plus 1 over 4. The denominators are the same, the bottoms are the same, so we just add the tops, and so we see 65 over 4. So that first mixed number is actually the fraction 65 over 4. Phew, all that work and we're not even done. Okay, now let's take a look at 6 1/2. If we take a look at 6 1/2, that's really 6 over 1 and a half, which is 6 over 1 plus a half. So I multiply the numerator 6 and the denominator 1 both by 2, 2 over 2, and we see 12 over 2 plus 1 over 2. The bottoms are now the same, and so what that means is I can just add the tops and put them over 2, and so I see 13 over 2. Phew! All of that fun work, but now we have the quotient. We're dividing two fractions. The fraction 65 over 4 divided by 13 over 2. And what do? We take that second fraction, whoop, we take its reciprocal, which is just a fancy way of saying flip it, and then we now multiply. So that 65 over 4 divided by 13 over 2 equals 65 over 4 times 2 over 13. Well, now if we actually take a look at that, we could simplify a little teeny bit. And you can see the 2 on top and the 4 on the bottom. We can simplify that to just 65 over 2 times 1 over 13. That makes it a little bit easier. And then when you multiply the numerators and multiply the bottoms, remember, when you're multiplying fractions, you multiply the tops and you multiply the bottoms. So in this case, we see 65 times 1, which is just 65. That was easy. Finally, an easy thing. And then 2 times 13, even that's not too hard. 2 times 13 is 26. So we see 65 over 26. And we could simplify that if you want to. Here's how I do it. Simplifying takes a little bit of time, but let me just show you how I do it. I'd write the 65 as 5 times 13, factor it, and then that's divided by 26, which is 2 times 13. We just did that, in fact. And notice now I've got a 13 multiple on the top and on the bottom factor, so I can simplify that to just 5 halves, 5 over 2. Now, 5 over 2 can be written as a mixed number, because remember, the original numbers were mixed numbers. It might be kind of fun to write this as a mixed number. 5 halves is really 4 halves and 1 half, which is 2 1/2. So 2 1/2 is the answer to this question. But what does that represent? Well, it represents the number of servings. So how many servings are in this 16 1/4 ounce container of Roberto's favorite yogurt? The answer is, we now see, it's 2 1/2. The power of knowing how to divide rational numbers is really, really phenomenal. And if those rational numbers look mixed, first convert them into a fraction that's bigger than 1, and then you know what you do with that second fraction. You flip it and multiply them all together. Have fun flipping, multiplying, and thinking about mixed numbers, putting them all together with division. And I'll see you soon.